Okay, well, we're looking at finding the horizontal shift, excuse me, that should say horizontal, and the vertex of a parabola. A parabola is the shape that you get when you graph a quadratic equation. So if let's just say the equation for this one is negative 16t squared plus 180t plus, let's say 40. Okay, because this looks like it maybe crosses here at 40 or something. No, not 40. I guess it'd be more like uh, 15. But whatever it is, when you're looking at the equation for one of these, the vertex is right at the very top or the bottom if it happens to be facing the other way. And so what we're going to be finding is the horizontal shift. In other words, how far did it get shifted to the right? And then what are the x and the y coordinates of that vertex? It turns out that the horizontal shift is this x coordinate right here, so that'll help us out. So I'm going to guess it's about 2.5 and maybe, I don't know, 120 or something like that. But that's what we mean by the horizontal shift and the vertex of a parabola. If you look at, I've got several equations here, and we're going to figure out what the horizontal shift is first by looking at the graphs of several of them, and then we'll see a pattern that allows us to get it done quicker. So I've got these graphed or set up here. I can turn them on and off as I wish. This first one, it looks like it's been shifted 3 spaces to the left. We're not going to worry about the vertical shift at this point. We're just looking at the 3 spaces to the left. And so I'm going to come over here to this and write -3 for that horizontal shift. And then let's look at the next one. That one appears to have been shifted 4 to the right. So +4, okay, +4. The next one looks like, let's see, I think it got shifted 5 to the left. And so we'll write -5. And then I'm going to ask you a question here. What does it look like? Is there any sort of pattern you see here? And here's what I begin to point out in class. That is the relationship between these numbers right here and these numbers there. Well, I noticed that every time I get the horizontal shift, it appears to be half of this number, but the opposite. So here's +10, so half of it and the opposite is -5. So it looks like we've established a pattern there. And if we were to go find another equation, let's say if I go graph another one down here, and we make it, let's say y equals x squared plus 4x. Okay. Yeah, it looks like it got shifted 2 to the left. So, uh, half of that, half of the middle number made the opposite. Looks like it worked. What if I make it negative? Oh, yeah. See, now it's shifted 4 to the right because half of -4 is -2, but make it the opposite, you get +2. So when I'm doing this in class, I let my students get really convinced that that's the pattern. And then I say, let's look at the next one. Okay, 2x squared plus 12x plus 20. And so turn this one off, turn that one on, and it looks like it got shifted 3 to the left. Uh-oh. Well, half of 12 is 6, and the opposite of that's -6. But it didn't go 6 to the left. It went 3 to the left. So let me write this in here. But that's a bit of a problem. What about this one? This one off. That one got shifted 4 to the left, but half of 24 is 12, make it the opposite, -12. It didn't go 12 to the left. It only went 4 to the left. So let's write that in here, 4 to the left. I'm hoping that the bottom one maybe does -20, but let's see what happens. Oh, great. It's +5. Okay. So we've gotten mixed up here. And what happens when I show lots of these in class, people eventually say, wait. You can still find half of this and make it the opposite, but then divide by this number. And so let me try that. Half of 12 is 6, make it the opposite, -6, then divide by 2. Oh, okay, that gave me -3. Let's try this one. Half of 24 is 12, make it the opposite, you get negative 12, and negative 12 divided by 3 is indeed negative 4. So this one, let's try it. Half of 40 is 20. Make it negative, negative 20, and then negative 20 divided by negative 4 is positive 5. So we did actually figure out a pattern. The only reason we didn't see that here is you can think of there being a 1 right here in front of each x squared. And in that case, dividing by 1 wouldn't have made a difference. So we didn't see it until we had something other than 1 right here. But that's actually the pattern. In general, you'll see this. They'll say the opposite of b over 2a. Okay? And you can see that's taking b, the middle number, dividing it by 2, making it the opposite, dividing by a. And you can do those in any order you want. That's usually the way you'll see it written. Okay? So that's how to find the horizontal shift. And so on this previous screen right here, if I had taken half of this number, made it the opposite, divided by that one, that would tell me what the horizontal shift is. I can't guarantee that this is the equation, so we're not going to worry about doing that. Okay? So the next question comes up, well, how do you get the vertex? So over here, how do I get the vertex? Well, here's the handy thing. The horizontal shift, the x-coordinate is the horizontal shift right there. Okay? So once you know the horizontal shift, you know the x-coordinate. So I could just start filling these in. 4 and negative 5 and negative 3, etc. Okay? Well, how do you get the y-coordinate, though? Okay, because the vertex has to be a set of coordinates. Well, here's the nice thing. Consider this equation right here to be a recipe for y-coordinates when you know the x-coordinate. Okay, so in this case, I know negative 3 is the x-coordinate, so I'll put negative 3 in here and there and calculate what the y-coordinate, because this formula gives me the y-coordinate. So negative 3 squared is 9. Okay. 6 times negative 3 is negative 18. And 9 plus negative 18 is negative 9. Plus 8 is negative 1. And if I go look at that graph there it is at negative 3, negative 1. Okay. On another one, let's try this one right here, the green one. I know that the x-coordinate is negative 5, so I'll put a negative 5 right there, and then calculate away. Now be careful, when you square a negative number, you are supposed to get a positive number. So negative 5 times negative 5 is positive 25. 10 times negative 5 is negative 50. And then plus 22. So let's see what we get. 25 minus 50 is negative 50. So, no, it's not. 25 minus 50 is negative 25. Plus 22 is negative 3. So hopefully on that green one, the vertex will be at negative 5, negative 3. Negative 5, negative 3. There it is. So that's how to find the vertex. Just once you get the horizontal shift, put that number in as the x-coordinate and then calculate the y-coordinate. Now lastly, the axis of symmetry, if you look at any one of these things, the axis of symmetry goes straight up and down right through the middle of that parabola. So it would, if I make a line right there, it would look identical on both sides. And here's the easy thing. If I just type in x equals the horizontal shift, because it shifted that far, there's the axis of symmetry right there. And so if I wanted the axis of symmetry for this one, I'd just type in x equals 5, and there it is. So on each of these here, if I want the axis of symmetry, I'll just type in x equals negative 3, because that's the horizontal shift. For this one, it would be x equals 4. And for this one, it would be x equals negative 5. So it just simply matches these numbers here. Okay, that should do it.